Okay, question 14. 1 kilo of water has a volume of 1,000 mils, so its density is 1 gram per mil. When heated at 25 degrees, this volume of water expands to 1,003 mil. So density just equals mass, volume equals the mass is still 1 kilo, so it's 1,000 grams divided by 1,003 mils equals whatever that equals. It's 0.997 grams per mil. So the answer is A. If we go to 16, two elements may be represented as shown. What information can be deduced from these symbols? Well, first off, bottom number is the atomic number. So, if we're looking at a periodic table, we've got oxygen and fluorine. So this is oxygen, this is fluorine, straight off. They represent the same element is incorrect because they are different elements. They represent isotopes of the same element, wrong because they're different elements. They represent different elements because the proton numbers are different is true. They represent different elements because their mass numbers are different is incorrect, so the answer is C. Look at 19. Which of the following chlorides is a polar covalent molecular substance? So, for it to be polar, it cannot be, it has to be non-symmetrical. Well, first off, it can't be sodium chloride because that is not a covalent molecular substance. Carbon tetrachloride or tetrachloromethane is symmetrical. We've got a carbon and a chlorine and a chlorine and a chlorine and a chlorine in a tetrahedral shape because it's symmetrical. Even though these bonds are polar, overall, because it's symmetrical, it is not polar. Next one, we have boron chloride. Boron's about the only thing that exists, just has 6 electrons in its outer shell and makes what's called trigonal planar. And once again, these are all 120 degrees. It is symmetrical around the boron, so even though the boron-chlorine bond is polar, itself is not polar. The answer has to be 19A. Three colourless liquids arranged alphabetically by name. We've got glycerol, hexane and water. Briefly outline a valid investigation that could be used to place these liquids into an order of increasing viscosity. So, I'm not going to write out the whole thing, but what you could do is get a funnel, pour identical volumes of each of those into the funnel and time how long it takes for them to go through. So in regards to this, the glycerol is the most viscous, then the water, then the hexane. So the glycerol will take the longest to go through, the water the next, and the hexane the last. And I just know that off because I know the actual substances. And let's have a look. Predict and account for the results you would expect to obtain from the investigation. So, glycerol has got 3 hydroxyl groups. Those 3 hydroxyl groups mean that it can make hydrogen bonds with other glycerol molecules, and 3 of them, effectively, for each glycerol molecule. And also the molecule is fairly large compared to, say, water. So glycerol molecules will tend to form hydrogen bonds with each other and therefore stick to each other, so they'll flow slower, and also the actual length of the molecule means that the molecules can get in each other's way when they're flowing, which means that, again, it has a high viscosity. Water would have the next highest viscosity, again because I've got hydrogen bonds between water molecules, so the water molecules will tend to hold on to each other and therefore have a reasonable viscosity. Hexane, even though it's a fairly long molecule, it is completely non-polar. There are only weak dispersion forces acting between the molecules, therefore it will have the lowest viscosity. So that would be predict and account for the results you would expect. Question 30. Some metal carbonates can be decomposed using the apparatus shown below. So we're heating up the carbonate. We've got some sort of a gas delivery tube here and some lime water. Identify a metal carbonate that can be decomposed in this way. Well, the one we used was copper carbonate. Why is lime water present in the flask? Because it shows the presence of CO2. Write a balanced equation for one of the reactions that would be observed during this experiment. Well, easiest one is the decomposition. That's a solid. It's going to give copper oxide, which is a solid, plus carbon dioxide, which is a gas. Okay, outlining the steps involved in recycling aluminium. So we're looking at effectively this step here. It is very straightforward. We have collection, we have separation, so that's removing all of the bits of paper, all of the foodstuffs, etc. that's caught inside. We have smelting, which is effectively melting it until it forms, you're forming new ingots, and then we have delivery of ingots to manufacturers. My scribbly writing. Okay, part B. Aluminium oxide is purified in the Bayer process, blah blah blah. Calculate the theoretical yield of aluminium hydroxide from 742 grams of alumina. So we've got 742 grams. So we have to work out the number of moles of that. So moles Al2O3 equals 742 over, we've got aluminium, which is 26.98 times 2 plus 3 times 16. So whatever that answer is. So we've got 7.27736 moles of alumina. That means we're going to get twice as many moles because this is 1 to 2. Okay, therefore moles AlOH3 equals 2 times 0.27736 equals 14.5547. Therefore, mass equals moles times molar mass is going to be 14.5547, etc., times the molar mass of aluminium hydroxide, which is going to be 26.98 plus 3 times 16 plus 3 times 1.008. Just get the answer for that. So we're going to go fair whack. 1135.32695, etc. grams. In the question we've got 3 significant figures, so my answer has to be to 3 significant figures, so it's going to be 1140 grams. And that's to 3 sig figs. Alright, back to question 24, B part 2. Gaseous sulfur trioxide is produced from the reaction of sulfur dioxide and oxygen gases as shown. Calculate the volume of oxygen required to fully react with 50 litres of sulfur. Okay, these are all gases. So we have got reacting gas volumes. So we've got 50 litres of sulfur dioxide So whole number ratios. Volume of oxygen is going to be 25. 2 volumes of this to 1 volume of that goes to give 2 volumes of that. So it's just 25 litres. A mixture of 15 litres of sulphur dioxide and 12 litres of oxygen is reacted. Calculate the volume of gas after reaction is complete. Okay, so I'm going to go write the reaction again. Plus oxygen, going to give 2 lots of SO3. We've got 15 moles of this, or 15 litres of that. We've got 12 litres of this. 15 litres of this needs 7.5 litres of that to react. Yeah? So, that's all going to be used up. So that's the limiting reagent. I've got 7.5 litres of that. I'm going to have 15 litres of that produced. I've got, what's that, 4.5 left. Litres left over. So my total volume is going to be the 4.5 litres of that plus the 15 litres of that. So I'm going to have 19.5 litres. That's the volume of gas after the reaction is complete. Okay, question 31. 10 grams of calcium chloride. Okay, was dissolved in sufficient water to give a final volume of 250 mils. Calculate the concentration of chloride ions. So we've got calcium chloride as a solid will actually dissolve to give calcium ions plus 2 chloride ions. Alright, got 10 grams. So I'm going to work out moles because our concentration has to be moles per litre. Moles equals mass over molar mass equals 10 over calcium is 40.08 plus 2 times 35.45 . Okay, so we've got 0.09 moles. Okay, concentration equals moles over volume equals 0.09 divided by the volume. So we've got 250 times 10 to the minus 3 times 10 to the minus 3 because it's got to be in litres. We've got 0.36 moles per litre. Now that's the concentration of the calcium chloride total. So the moles of the chloride ion is going to be twice as much. Okay, so I'm going to have equals 0.72 moles per litre chloride ions. Okay. Draw diagrams to show the interactions between the water molecules and the chloride ions when calcium chloride is dissolved in water. So we've got calcium 2 plus and we've got chloride. We've got chloride. Effectively what happens, and I've got calcium here, and you get a water molecule. So the positive ends of the water molecules to the hydrogens come and surround a chloride, etc., and drag it off. So I'm going to have a chloride surrounded by the hydrogens of water molecules because they are positively charged, partially positively charged, okay, etc. And the calcium ions is going to be opposite. Because the waters are partially negatively charged. Methane is completely non-polar because we've got hydrogens and carbons, so that is actually if I've got a carbon and a hydrogen, it is slightly a polar bond. However, because this is a tetrahedral symmetrical shape, the polarities cancel out and it is non-polar. And as like dissolves like, methane will tend to bond to itself rather than bonding to water. And in this case, it's a gas anyway, and it will not form. The only bonds it will form with the water are dispersion forces, and the water molecules will actually hold on to each other much tighter than they would to the methane. So the methane is insoluble. Alright, 32. Element X forms a fluoride of formula XF3. 2.45 grams of this fluoride is dissolved in enough water to make 200 ml of solution. The molarity of the final solution was found to be 0.15 molar. Okay, sketch and name the appropriate piece of glass we use to accurately create the 0.15 molar. Okay, so we have got a volumetric flask with a stopper or some diagram. Okay, we want 200 ml, so this would be a 200 ml volumetric flask. Alright, so what have I got to work with? 2.5 grams made up to 200 ml. Okay, so concentration equals moles over volume. Now, what have I got? My 0.15 molar equals the number of moles divided by the volume, which is 200 times 10 to the minus 3. Therefore, number of moles equals 0.15 times 200 times 10 to the minus 3. Which is 0.03. Okay, so I can say 0.03 moles equals 2.5 grams. Therefore, 1 mole equals 2.50 divided by 0.03 grams. So I'm just dividing both sides by 0.03. So 1 mole equals 83.3 repeater grams. Okay. So XF3 equals 83.3 grams. So X plus 3 times 19 equals 83.3. So X plus, what's that, 57 equals 83.3. So X equals 83.3 minus 57, whatever that is. 26.3 grams. Okay, so that's the atomic weight of element X. And that's that. Okay, the last bit of this question is a likely identity for the element. Well, if we look at the periodic table, our mass calculator is 26.3. The closest one is 26.98. So closest element equals aluminium, and also aluminium is Al3 plus, aluminium ions, and we're talking about F, 3 lots of F, so it once again also formed AlF3, which is very similar to our XF3, so it's more than likely aluminium.